see if anyone else rolls at our door. Let me get the screen set up here. Whew. All right. It is after spring break, which means April is next week. And April means May is almost. Boy, we're about to wrap up with school, guys. It all just kind of goes downhill after we get past spring break. So this is that last final push. Hopefully, you guys got some rest over spring break and ready for that big push to finish the year. If any of you are behind in the class, hopefully you made some good use of your time last week, because you had a lot of free time. You didn't have any classes. You didn't have any new assignments. So, man, what a great time to get caught up if you were behind. I have not updated the grade book this week yet. Yesterday, I was still in the fog. I feel pretty good today. I finally a couple nights sleep. I think I'm feeling like a person once again. But if you were behind, hopefully you got a lot of things turned in. Like I say, I'm trying to get grades updated. I haven't made it yet, but I will get that done today at some point for everything that you guys have done through spring break. Most of you were right on top of it already. Hopefully you didn't have to work over spring break, but if you needed to work over spring break, hope you got a lot of that done to make this last push a lot easier on yourself. So let's pull up our algebra this morning and get things going. All right, let's go to our grade screen as usual to see what we're looking at. We're actually going to be pretty busy next few weeks. So that's why I hope you got caught up, because you're going to have a few assignments. Now, these assignments do not take very long. That's the good thing about it. But look, this week we have 4 assignments this week. 2 on adding and subtracting matrices and 2 on multiplying matrices. And then next week, look, we've got 5 things and then 6 things. So again, these are generally pretty short, pretty quick assignments. So it's still, it's not like you're going to spend 3 hours doing these unless you really, really very slowly go through it. If you need to go through it very slowly, that's fine too. But it shouldn't be like 3 hours of assignments. But if you need that time, take it. Some people take 3 hours of assignments on the ones we do now. So, all right. So we're going for adding, subtracting, and multiplying matrices by scalars. Now, this is just scalar multiplication. Next week, we're going to get into multiplying 2 matrices together. That's different. Scalar multiplication is much simpler. So let's go to our activity screen. Okay, intro to measure. I'm closing that folder. Elementary operations, closing that folder. And quiz 1, that's what we did before the break. So you should be caught all the way up to there. So we're doing these 2. We looked at the grade screen. It said adding and subtracting and multiplying. So let's open up the adding and subtracting. And let's look at these 2 lessons. And then we'll look at those 2 assignments. So the video lesson, let's see what they have to say about matrix addition and subtraction.
Let's think about how we can define matrix addition. And mathematicians could have chosen any of an arbitrary number of ways to define addition, but they've picked a way to define addition that seems, one, to make sense, and it also has nice properties that allow us to do interesting things with matrices later on. So if you were one of these mathematicians who are first defining how matrices should be added, how would you define adding this first matrix over here to the second one? Well, the most common sense thing that might have jumped out at you, especially because these 2 matrices have the same dimensions. This is a 2 by 3 matrix, has 2 rows and 3 columns. This is also a 2 by 3 matrix, 2 rows and 3 columns, is to just add the corresponding entries. And if that was your intuition, then you had the same intuition as the mathematical mainstream, that the addition of matrices should literally just be adding the corresponding entries. So in this situation, we add 1 plus 5 to get the corresponding entry in the sum, which is 6. You can add -7 plus 0 to get -7. You can add 5 plus 3 to get 8. You can add, and I'm running out of colors here, you could add 0 plus 11 to get 11. You can add 3 to -1 to get 2. and you could add negative 10 plus 7 to get negative 3. And if you see this definition of matrix addition, you see that it actually does not matter in what order that we actually add these matrices. I could have done this the other way around. If I did this the other way around, let me copy and paste this. So if I were to add this matrix, so let me copy and let me paste it. If I were to add it this way, that matrix to, let me copy and paste the other one, to this matrix. So copy and paste. If I were to go this way, you'll see that the order in which I'm adding the matrices does not matter. So this is just like adding numbers. A plus B is the same thing as B plus A. What we'll see is that this won't be true for every matrix operation that we study. In particular, this will not be true for matrix multiplication. But if you add these two things, using the definition we just came up with, adding corresponding terms, you'll get the exact same result. Up here we added 1 plus 5 and we got 6. Here we'll add 5 plus 1 and we'll get 6. We get the same result because 1 plus 5 is the same thing as 5 plus 1. Here we had 0 plus negative 7. You get negative 7. So you're going to get the exact same thing as we got up here. So when you're adding matrices, if you were to call this matrix right over here matrix A, which we normally denote with a capital bolded letter, and you call this matrix right over here matrix B, then we take the sum of A plus B, which is this thing right over here, and we see it's the exact same thing as matrix B plus matrix A. Now let me ask you an interesting question. What if I wanted to subtract matrices? So let's once again think about matrices that have the same dimensions. So let's say I'm going to have two 2 by 2 matrices. So let's say it's 0, 1, 3, 2. And from that, I want to subtract negative 1, 3, 0, and 5. So you might say, well, maybe we just subtract corresponding entries. And that indeed is how you can define matrix subtraction. In fact, you don't even have to define matrix subtraction. You can let this fall out of what we did with scalar multiplication and matrix addition. We could view this as the exact same thing as taking 0, 1, 3, 2, and to that we add negative 1 times negative 1, 3, 0, 5. And if you work out the math, you're going to get the exact same result as just subtracting the corresponding terms. So this is going to be, what is this going to be? 0 minus negative 1 is positive 1. 1 minus 3 is negative 2. 3 minus 0 is 3. 2 minus 5 is negative 3. And you'll see that you get the exact same thing over here. When you multiply negative 1 times a negative 1, you get a positive 1. Positive 1 plus 0 is 1. Negative 1 times 3 is negative 3. Plus 1 is negative 2. Fair enough. There might be a question that is lingering in your brain now. Okay, Sal, I understand. When I'm adding or subtracting matrices with the same dimensions, I just add or subtract the corresponding terms. But what happens when I have matrices with different dimensions? So, for example, what about the scenario where I want to add the matrix 1, 0, 3, 5, 0, 1 to the matrix, so this is a 3 by 2 matrix, and I want to add it to, let's say, a 2 by 2 matrix, 5, 7, negative 1, 0. What would we define this as? Well, it turns out that the mathematical mainstream does not define this. This is undefined. This is undefined. So we do not define matrix addition or matrix subtraction when the matrices have different dimensions. There didn't seem to be any reasonable way to do this that would actually be useful and logically consistent in some nice way.
All right, so the big thing to take from that is if they are not the same size matrices, you cannot add or subtract them. Now, we'll find out next week. There are some things we can do with different size matrices, but as for this week, you cannot add and subtract matrices unless they're the exact same size. Same number of rows, same number of columns. That's the big thing to get in that. All right, so let's put this back up on the screen. There we go. So that was the adding and subtracting matrices video. Now let's look at the lesson that goes with that video. And you always have these. If you need to go back and review that, you do have that right here in Buzz for you. Adding and subtracting matrices lesson. Oh, and they're looking for donations right now. Just close that window. Close that window. Okay, here's what we're looking for. So adding and subtracting matrices. Now it always starts with a little refresher. What do you need to know before this? You need to know how big this is. This is 2 rows, 3 columns. So this is a 2 by 3 matrix. This is, if you don't remember that from before spring break, you can check out the intro to matrices lesson. All right, so we're going to talk about adding matrices, which he just showed us in the video. So if we have a matrix A and a matrix B, and we want to find A plus B, it's actually very simple. A plus B is take matrix A and matrix B and add them together. So the entries that are in the same position, like the 4 and the 1, those can be added together. 4 plus 1 becomes 5. 8 plus 0. 8 plus 0, 8. We're going back to first grade math here. I'm going to take it easy on you guys. 3 and 5 are in the same position. So 3 plus 5 and 7 plus 2. All right, so adding matrices is not difficult. You just have to say, I can only add the element that's in row 1, column 1 to another element that's in row 1, column 1. I can't add the 4 and the 0. They're not in the same place. All right, so it wants to check our understanding here. Again, I'm going to make sure I can see the chat here for you guys. So with matrix A being this matrix and matrix B being this matrix, what are we going to put in the first row if we add A plus B? What two numbers are in our first row? Just to make sure the class is understanding this. Mackenzie's got it. Anyone agree with that? Anyone disagree with that? Zoe's going to agree with that. All right, Eliana agrees with that. Got a few folks. And Autumn. So yeah, we take the 5, which is in the first row, first column, and the 2, which is in the first row, first column, add those together. And then we take the 2 and the 3 and add those together. So there's our first column. There's our first row. Okay, second row. You just have to be careful you're adding the same elements together. All right, I'm seeing 4 and 2. All right, last row. Oh, last row gets tricky. We're getting to double digits. Oh, my goodness. Still, we're first grade math. Double digits. 1 plus 0, 9 plus 2. We could check, but we know we got that. All right, good job, guys. Check understanding. We won't do this one. It's just a 2 by 2. We'll skip that for the interest of time here. Remember, you always have access to these. You can come do all of these yourself if you're not sure you're understanding. Subtracting. Subtracting works exactly the same way. It's just we subtract instead of add. So if we have C and D and we want to subtract them, we just have to do the elements that are in the same position. 2 minus 5, 8 minus 6, 0 minus 11, 9 minus 3. So we end up with -3, 2, -11, and 6. So we can walk through this real quick. So we have 4 that's in the first row, first column, and we have 1 that's in the first row, first column. 4 minus 1. 16 and 15. 16 minus 15 is 1. 10 minus 6. 22 minus 3. Check. All right, so addition and subtraction are really, really very basic. Back to first grade math. The only tricky part is we just have to make sure we're lining them up properly. But it's just simply taking numbers and adding them together or subtracting them. And there's just a bigger one, but it works exactly the same way. If you have a 3 by 3 matrix and you're subtracting a 3 by 3 matrix, you will end up with a 3 by 3 matrix. It'll end up exactly the same size because you're just going through all of it. 3 minus 1 is 2. 4 minus 6 is I didn't tab over. Negative 2, 9 minus 7 is 2. Lots of 2's in that one. We won't go through that whole thing. Let's go to scalar multiplication. Oh, this is scalar multiplication as repeated addition. All right, so we're just showing you that with matrices, a lot of the same properties we already know also apply. So if we have this matrix A, and we say we want to find A plus A plus A. So I think, how would you do that? Exactly the way you think you would do that. You would take matrix A and add another matrix A and add another matrix A to it. So you list the matrix 3 times. And you add 4 plus 4 plus 4. Or 8 plus 8 plus 8. 2 plus, which means that's the exact same thing as 3 times 4, right? Because we know that property too. If we're adding the same number together 3 times, we can just multiply that number times 3. So this is the same thing as 3 times 4, 3 times 8, 3 times 2, 3 times 1, which means we didn't even have to do that. We could have just said 3 times whatever matrix A was. So adding the same matrix together 3 times is the same thing as just taking the matrix and multiply it by 3. Exactly the same way we do with other numbers. If we have 7 plus 7 plus 7, we can just take 3 times 7. It's the same thing. So it works with matrices as well. So that's nice to know that a lot of the stuff that we already know, we can just apply to matrices. And it works perfectly. And subtraction is the same as adding the opposite. If we want to take 7 minus 5, we could do that, or we could take 7 plus negative 5. And either way, we would get 2. So A minus B could be A plus negative B. Generally, we would think subtraction probably before we would think of adding the negative of the number, but it works just the same way. All right, let's go back and see what's next. What's next? Oh, here's our first 2 assignments this week. So after we watch the video, after we've gone through the lesson, now it's going to have 2 assignments on exactly what we just learned. So let's click the first one, add and subtract matrices. Close that window, close that window. All right. You see, I'm on problem 3 of 4 because I've already done 2 of these. But it's have 4 problems. 4 problems. Find the values of X and Y. Oh, so for this problem, there's an X right there in the first matrix. There's a Y in the second matrix. And it wants to know what numbers would make this true. Yeah, if we're subtracting the second matrix from the first one and ending up with this, 5 minus negative 3 was 8. Something minus 2 equals negative 5. What would X be if we subtract 2 from it and end up with negative 5? Little trickier when we get to negative numbers. X minus 2 equals negative 5. How would we end up with negative 5? We subtract it. Oh, we got 2 different answers right now. We got negative 3 and negative 7. So I say sometimes we get a little tricky with the negative numbers. I'll show you a way to maybe help be a little less confused since we're getting differing answers. This is good. I was hoping we'd get differing answers. So X minus 2 equals negative 5. Well, the easiest way to solve that is I can write it down like this. I don't think you're focused too well there. That's a little better. And just solve this. X minus 2 equals negative 5. So if I add 2 to both sides, X equals negative 5 plus 2 is negative 3. It's a negative 3. We can just write it down as a math problem. X minus 2 equals negative 5. All right, so we know the answer now would be negative 3 for that. And here we have negative 1 minus Y equals negative 6. Oh, let's write that one down. That looks like a good one. Negative 1 minus y equals negative 6. Okay, so that was a negative 6, right? Woo. Yeah, okay. Just making sure I wrote it down right. So we can solve this. Let's see. Let's add 1. So negative y equals negative 5. So divide by negative 1 to make that a positive y. Y equals 5. Y equals 5. All right, so if we put 5 in there, let's check to see if we're right. Down the corner. Good work. You got it. Onward. And then this one is just find the difference. So we're just subtracting. Negative 1 minus 1. Oh, negative 1 minus 1 more is negative 2. 3 minus 4. Negative 1. 4 minus 3. Do it both ways. 1 minus 0. Well, that one ended up just a very simple one. Check. So show summary. Here's where I'm taking my screenshot. There it is. 3 out of 3. I did 4 problems. But anyway, when that comes up, you take your screenshot of the screen. I don't know why it counted 3. I had 4, but go back here, scroll down, paste your screenshot. So it's got your score, it's got your name up in the corner. Submit. All right, let's go back and look at the next assignment. That was the first assignment. Now we got matrix equations, addition and subtraction. So when I go to that, let's see what kind of problems it has for our second assignment. Close that window, close that window. All right, I'm on 2 of 4. I've only done one of these. We'll do one of these and we'll move on. Okay, solve for x. So we have a matrix plus x equals another matrix. So x is obviously a matrix of some kind. And let's see, I'm going to turn this paper over and write this down real quick. So it gives us this problem here. It wants to know what x is. Well, x is going to be another matrix, right? We just named the matrix x. So basically it's asking if we have 5, 5, negative 7, 2, 3, negative 6, what would this matrix need to be for it to equal 1, 1, 5, 4, negative 2, and 9? So this is what we got to figure out. 5 plus something equals 1. Well, if you need to write those down, you can do 5 plus x equals 1 and solve that for x. Subtract 5 from both sides. X equals negative 4. This must be negative 4. 5 plus negative 4 equals 1. Oh, and the second one's exactly the same. 5 plus something equals 1. Well, we know it's negative 4. Negative 7 plus something equals positive 5. Negative 7 plus x equals 5. Add 7. X equals 12. So this must be a 12. Negative 7 plus 12 would equal 5. 2 plus what equals 4? Well, 2 plus 2 equals 4. 3 plus something equals negative 2. So 3 plus negative 5 would be negative 2. And negative 6 plus some number is going to get us up to 9. So that's going to be what? 15. Negative 6 plus 15 equals 9. So we would go back and put this in as our answers back in our quiz here. Now, it gave us a 3 by 3 just to try to fool us. We know the answer has to be the same size as the other 2 matrices, or we could not add them together if it wasn't the same size. Negative 4, negative 4, 12, 2, negative 5, 15. Yep, I think that's all the numbers we had right there. Nice work. So anyway, we would do that. Then we would go back here, scroll down, take our screenshot showing our score, submit that. Let's go back to and see what we got next. Okay, I'm going to close that folder since we're finished with the adding and subtracting. That's half of our assignments for the week. We also are supposed to do multiplying by scalars. So let's take a look at multiplying by scalars. Oh, we have another video to show us how to do this. Multiplying matrices by scalars is not complicated. Again, don't try to overcomplicate it and think, oh, this is really no, this is not really hard.
Now that we know what a matrix is, let's see if we can start to define some operations on matrices. So let's say I have the 2 by 3 matrix, so 2 rows and 3 columns, and the entries are 7, 5, -10, 3, 8, and 0. And I want to define what happens when I multiply 3 times this whole thing. So first of all, let's get a little terminology out of the way. The number 3 in just the everyday world, if you weren't dealing with matrices or vectors, and if you don't know what vectors are, don't worry about them just now, you would just call that a number, or you would call this a real number. It's just a regular number sitting out there. But now in the world where we have these new structured things, these matrices, these arrays of numbers, we will refer to these just plain old real numbers that aren't part of some type of an array here. We call these scalars. We call this a scalar. So essentially what we're defining here, we don't know, I haven't said what this is actually going to turn out to be, but whatever this turns out to be will be a product of scalar multiplication, or we're multiplying a scalar times a matrix. And so how would you define this? What do you think this should be? 3 times this stuff right over here. Well, the world could have defined scalar multiplication however it saw fit, but one way that we find perhaps most obvious and most useful is to multiply this scalar quantity times each of the entries. So this is going to be equal to 3 times 7 in the top left, 3 times 5, 3 times -10, 3 times 3, 3 times 8, and 3 times 0, which will give us, it didn't change the dimensions of the matrix, it didn't change, I guess you could say, the structure of the matrix, it just multiplied each of the entries times 3. So the top left entry is now going to be 21. The middle entry, or the entry in the middle row top column is going to be 15, -30, 9, 24, and 0. So when you multiply a matrix times a scalar, you just multiply each of those entries times that scalar quantity.
All right, much like we would expect that to be. It's very, very simple. If you have a number out front of the matrix, it's scalar multiplication. You're just taking that number and multiplying it by every entry in the matrix, so regardless of how large it is or what size it is. So that is pretty straightforward, and don't make it more complicated. It is that simple. So after looking at that, we have the lesson that goes with it. It'll tell us basically the same thing, but we'll go into a few more pieces of it. I'll close that window, close this window. Again, what you should be familiar with is how to tell what size a matrix is. And it's got a couple of things you can review if you need to go back. All right. Scalars and scalar multiplication. As he just showed us in the video, if we have a matrix A like this, and we want to find 2 times A, or 2A, we just simply take what's inside matrix A and multiply each element by 2. 2 times 10. So now 10 and 6 become 20 and 12 because we multiply them by 2. In the second row, 4 and 3 become 8 and 6. Like, Mr. Brock, I'm really liking this week in matrices. We're doing first grade adding and subtracting and second grade multiplication, right? This is great. Okay, this may be third grade. I'm not sure. We're multiplying by a negative here. I don't know when you started multiplying by a negative number. But you had to learn regular numbers before you went to negative numbers. -3 times b. So if b is -4, -2, 7, and 1, we just multiply those numbers by -3. -3 times -4. Well, that's a positive. -3 times -2, positive. -3 times 7. Now we got a negative number. And -3 times 1, -3. Just exactly what we thought it would be. Just taking the scalar number, multiplying it, check mark. Got it. All right, I'm going to let you guys do this one. This one's only got 3 numbers. But this is a little bit beyond our second grade multiplication because we're dealing with fractions now. I'm going to say, don't let the fractions confuse you. We are simply taking negative 42 and multiplying it by a third. Now, when you multiply by 1/3, you can also divide by 3. That's the exact same thing because you're finding 1/3 of negative 42. So who knows what that is? 1/3 of negative 42. What's 1/3 times negative 42? 1/3 of that, or negative 42 divided by 3. We'll also tell you what a third of negative 42 is. Mackenzie's got it for us. Zoe's got it for us. Yeah, negative 14. We know it's going to be a negative because it's a negative being multiplied by a positive. All right, how about 1/3 of 27? 1/3 times 27. That's going to be a positive number because they're both positive. So, yeah, 1/3 times 27 is just 9. Because 9 plus 9 plus 9 is 27. So 9 must be 1/3 of 27. Because if you take it and add it to itself 3 times, you'll get back to the 27. And 1/3 times negative 3. Yeah, negative 1. That one's not bad. All right, check. Oh, there it is. Got our check mark. Wonderful. And that's the end of that lesson. Like I say, very short, very easy. All right. You just simply, if you need to get a calculator to multiply by 1/3, do that. All right, that's the lessons for multiply. Let's look at the other 2 assignments that go with this. Multiply matrices by scalars. Again, we'll paste our results down here. Window, close that window. Up, 4 questions. Okay, let's go. We'll answer the first 1 or 2 here. So we have find the product when we multiply negative 2 times this matrix. Negative 1, 3, 4. And starting off with is pretty easy, right? Negative 2 times negative 1 is a positive 2. Negative 2 times 3 is a negative 6. Negative 2 times 4 is a negative 8. Negative 2 times a positive 2, negative 4. Oh, I don't need to show the calculator. I hit the wrong button. Check. That's what I want to do. Good work. Keep going. Next question. Let's see. Oh, see, now they're getting trickier with us. 1/2 times this matrix equals this matrix. So it wants to know what is x. All right, I'll let you answer x and y here, and then I'll close this assignment out because you guys got to do this assignment on your own here too. So 1/2 times x equals 2. You guys got this? Yeah. 1/2 times 4 is 2. 1/2 of 4 is 2. We know that. How about the y right there? 1/2 times y equals 4. Yeah. So they gave us some nice simple ones. And we didn't even have to get into the negatives. But check. All right. So at the end, we would take a screenshot of this. When we're finished, we'd say, okay, I got them all right. There's my screenshot. I go back and say, there it is. I got them all right. Submit my work. I didn't finish it, but you would finish it and submit that. And go back. Let's look at the other assignment that we have on matrix equations because it'll probably be a little bit different way. Let's see if it's trickier or what they do to us here. All right, there we go. Got us in there. Oh, yes. This is a little trickier because it's combining. It's combining adding matrices and scalar multiplication. So perhaps we should write this one down. All right, so 3x, just because I don't want anyone to be confused because this looks a little bit different. It's just combining the skills we've learned today. It's really not anything that's harder. It's just you got to pay a little bit more attention when we're combining what we're doing. Okay, so what it's asking us to do is find matrix X. and X is a matrix. And it should be the same size because we're adding it to this one and we get an answer. So what is it? And on top of that, it's being multiplied by a scalar. So really, they just showed us 3x, but if we want to see the whole thing, we can say, okay, we can rewrite it with the matrix there if it helps us keep that straight. So it's wanting us to find 3 times this matrix and add this matrix to it to get this matrix. So if we need to, since this is just X, this is matrix X, we can write this as a problem like 3 times X plus -1. Plus -1 is the same as subtracting 1. I could just say -1 by adding a negative. What's that equal? Well, what's the first thing? Equals 11. So this is saying what is X if 3 times X minus 1 equals 11? Well, let's add 1. It's just a algebra problem now. 3x equals 11. Divide both sides by 3. So x equals 4. So the first entry in x must be 4. 3 times 4 plus -1 equals 11. Okay, so what's the next one? Let's find this one. 3 times x plus 1 equals 4. Subtract 1. 3x equals 3. So x equals 1. So this must be a 1. That's all you're doing on this. You're just trying to find each entry for x to where we would add this number and equal this. So that would be a 4. That would be a 9, 2, -17, 0. So you're just finding the numbers to be true. 3 times something plus nothing equals 9. Well, 3 times what equals 9 then? Well, that must be a 3. 3 times something plus 8 would equal 2. 3x plus 8 equals 2. Subtract 8. 3x equals -6. So that must be -2. 3 times something minus 5 equals -17. 3x minus 5 equals -17. Add 5. 3x equals -12. So this must be -4. 3 times -4 would be -12. This adds 9 and ends up 0. So it must be -9. So 3 times -3 would be -9. And then if we add 9 to that, it would give us 0. -14. 3x plus 4 equals -14. Just solving for x. -18. 3x equals -18. So that's -6. -12. 3x plus 3 equals -12. Minus 3. 3x equals -15. So that must be -5. Then finally, 3 times something minus 1 equals 5. So before we subtracted the -1, it must have been 6. So it must be 3 times 2. So let's go fill this in and see if we got it right. So we said the answer would be 4, 1, 3, -2, -4, -3, -6, -5, and 2. We had a lot of negatives in there. Let's check. But we got it right. So that's what this one's doing. Just making it look more complicated. Show my summary. I got 2 out of 4. Well, I didn't do the first 2. But anyway, so if I got 2 out of 4, I could take a screenshot of that and say, okay, there's my score. Now, the nice thing is, if I want to, I can go back and retry it. Down in the left corner, it says try again. If I do that, I say I want to get 4 out of 4. I can start over. Starts out 1/7 x minus this equals this. So you don't have to settle for 2 out of 4 if you get 2 out of 4. You can go back and redo it if you like. But that is both the multiply assignments. So we did the 2 addition and subtraction assignments, the 2 multiplication assignments, scalar multiplication, and we'll save this stuff for next week. Next week, we'll do these 3 folders and the quiz. All right, guys, this is an A-Day Friday, so we only have class again on Thursday. So if you are working with this and struggling, come see me Thursday. We'll do some together and help get you straightened out. But don't overthink this. Really, you're just adding and subtracting numbers and multiplying by a number. So if your grade's below 70%, I'll see you Thursday. Otherwise, guys, go have a great week. And we'll see you in April then, if I don't see you Thursday.